yes, you can't see. So, on your Matter Pro, there's two sides. One is about pizza dough, and the other one is about the lemonade. Okay? So, the first one is the pizza dough. So, I have my pizza dough. Okay? Starts off talking about it being in a ball. Okay? I took the mass, because I use a what to find the mass?
Triple beam balance.
Okay? I believe I did it in my first class. Yes, it was 8 grams. Okay? The mass of my pizza dough was 8 grams. Okay? Having a ball. Now I'm going to pull it out. I'm going to smush it out, smush it out, smush it out, and make it into a pizza. What has changed?
It's
Who said that word?
volume.
Because I changed the size and how much space it took up. So let's go back to define what mass is. What is mass? What is mass, Ethan?
The stuff in an object.
The stuff. It's the stuff that it's made up of. Did my stuff change when I went from a ball to a pizza?
No.
My mass is not changed. So if I were to go on here, guess what? It still should be 8 grams, which it is. Okay? When does my mass, so my mass did not change. My volume absolutely changed. Before, it was in a ball. It probably has a tendency, if I put it in water, it may what? Sink. But if I flattened it out and made my volume larger, it probably would what? Float. Because my volume is larger than my mass. Okay? So think about that when you're reading your pizza dough. Now, the other one was weight. What is the definition of weight? What is the definition of weight? Jaden.
The gravitational pull on the object.
Gravitational pull of the object. Excellent job. So, now, gravity's pulling this down. How do I know gravity's pulling it down?
Because
it's down. My necklace is being pulled by gravity because it is being pulled down. If not, it would be flying around. It would not look what it's supposed to. Okay? So, gravitational pull. Is the gravitational pull changing when I have it flat like a pizza, square, a ball, anything?
No.
Where does the gravitational pull change? Space or
no gravity.
Or somewhere with no gravity, which is your space, or your moon, which is a fixed up. Okay? So, my weight is not changing, ladies and gentlemen. It only changes when I go to the moon or outer space or somewhere has less. Now, less gravitational pull. Even still, the farther up you go in the atmosphere, it's going to have less and less of a gravitational pull. So even thousands of miles up in the air, you're going to have a less of a gravitational pull because you're getting farther and farther away from the pull of Earth. Okay? So, think about that when you're filling it out. Second thing I do want to talk to you about is this. I have water. I'm going to quickly find the mass of my water. You all should have paper in front of you because you got your station paper out. Okay, hang on. 317. Remember that number, 317. Write that number down. 317 is my, is that my water?
Grams. No.
Wait, no.
It's the water and container.
That's the container and nice job, Kaden. Container and the water. So for this particular experiment, because I'm not being that scientific and that perfect, this is 317 grams is the mass of my water in my container. Okay? So now I'm going to put over here my salt. I've already pre-measured my cup, and I know my cup is 2 ounces. Okay?
Use the pencil. Wow.
Alright, so my salt, my salt is 39.5 grams. So if my salt and cup 39.5 and my cup itself was 2 ounces, what's the true mass of my salt?
37.
37 what?
Grams.
37.5. All right. So my grams. So let's go back over here. Now watch this. And I'm going to turn it around. So first of all, let me figure this out, and then I'll turn it around so you can see. So if I'm going to put my water right here, which was 317 grams. This is a big question on that lemonade thing. 317, and I have 37.5 grams of salt. When I add my salt to my water, is that going to change the mass of my water?
Yes. No. Yeah. Because it's adding more weight. Yeah, because
It's not adding weight, it's adding what?
more
Mass.
mass.
Am I adding something in here?
Yes.
What am I adding in here?
Salt.
37.5 grams worth of salt. So right now, I'm going to write it on here just a little bit bigger for you guys to see. 317 is my water. And I'm adding 37.5 grams of salt. I want you to think about it for a second. What should be my total mass of my water and salt once I add my salt in there? 317 grams for my water, 37.5 grams for my salt. What should be my total mass, or how much should this weigh? What do you think, Gabby?
I thought
354 and 5/10. Why did you do that?
Because I did 317, 37 and 5/10, since we're adding the salt and water.
But I have a quick question though. Raise your hand if anybody got anything different than 354 and 5/10. Gabby, what do you think? Cassie, what do you think?
I lined up my decimals and got 40 and 67.
But you're having the mass of the water plus the salt. Kaden, what do you think?
I got 354 and 5/10 grams.
Okay, that's exactly what.
Exactly what she said for grams.
So, here's my. But I have a question though. So here it is. You're telling me, both Kaden and Gabby said, once I add my salt, it should be 354.5 grams. But I have a question though. If I add this, I know, because we talked about mixtures and solutions, that I know that my salt is going to dissolve. Is that a true or false statement?
That's
It's a true statement, okay, because this is now making a solution, and we know that. So, is it going to be less than if it dissolves?
Yes, because the water's in it.
Okay. So let's just see. We know that it's going to dissolve. That's a true statement already. It's even, isn't it?
Yes. No.
Yes, it is.
Almost. Yeah.
Okay.
Yes.
So, it is. Is it true that my salt dissolves?
Yes.
But what do we know?
Salt.
The water sucks it in and absorbs it or dissolves it, but it's still what? It's still salt and it's still in there. How do I know it's still in there?
Because you can
Jaden.
see it. You can see it.
Jaden?
Because if you taste it, you'll still be able to taste
So it's in there, so it still has, it's kept the property of its taste. How else can I prove that the 37.5 grams of salt is still in there?
It'll evaporate.
You can evaporate the water, which leaves the what?
Salt.
Salt. And how much salt should I have? 37 and 5/10 of 37 and a half. So even though my substance, which is my salt, it could be my Kool-Aid, it could be whatever, sugar, whatever, even though it dissolved, guys, it's still in there. And I just proved it right there. Even though you think, oh, it dissolves, it can't all be in there. It's still in there. How do I know? I take the water out and I evaporate the water, and it's no longer there.
Miss White.
But let's guess what's left. My salt. Okay? Question.
At first, I thought what was going to happen was when the salt dissolved in the water, I thought it was going to like evaporate with it, but then we did the experiment and it stays.
Just because, how do I know that only my water evaporates? I don't have a green cloud.
Yeah.
I don't have a green cloud over my food coloring. So I know, and we proved the other day that the food coloring stays back because I added more water, it was green again. All right. Sandra, press that button.